Okay, good morning everyone. Thank you for joining for today's session. Let me first apologize. Yesterday I had a huge power connection and hence I was power problem and hence I was not able to join yesterday. Nonetheless, let me quickly revise what we did at the class before that and then we can continue from here. So the class before that we started talking about Numpy, and Numpy is basically standing for numerical Python. It is our package that we'll be using for doing linear algebra, calculus, and so on. It is one of the foundational packages for most common data science packages. Additionally, it promises us high performance multi-dimensional arrays for vectors or matrices. The key features of Numpy are n-dimensional arrays, which are fast, convenient, and space efficient. Additionally, there are two more features that we'll be discussing later down in the class, broadcasting and vectorization. Okay. We saw how to create rank 1 arrays and rank 2 arrays. That is basically one-dimensional arrays and two-dimensional arrays, depending upon how we pass elements to np.array. np.array helps us to create n-dimensional arrays for Numpy. If we pass one list, it creates a rank 1 object. And if we pass a list which is comprised of multiple lists, then we pass we get two-dimensional arrays or rank 2 arrays. Numpy conveniently interprets these lists as multiple rows, and then thus we have the concept of rows and columns, which is the same concept that we use in matrices. Okay. We further go and we look at there are different ways of creating arrays using functions, using np.zeros, which helps us to create matrices with all elements as zeros. We see np.full, which helps us to create matrices with all elements as full. np.I, which helps us to create identity matrices depending on what size we pass here. We look at np.ones, where we create an array with all elements as ones. And we also look at np.random.random, which helps us to create matrices with all random values. So this function random creates values in the range of zeros to ones. And finally, we ended our discussion last time after talking about integer indexing, slice indexing, and Boolean indexing. These are three different ways of indexing matrices. Integer indexing being the simplest one, that is we provide one row and one column index, and we are able to fetch using this one index of integer and column one value from the respective array. We can also do something called a slice indexing, which we saw where we can put a series of items for rows and series of items for columns. So multiple rows and multiple columns we can select using slice indexing. And then finally we saw Boolean indexing, which basically creates a Boolean matrix of trues and false. And this can be used as a filter to extract items from the array. Let us look in the notebook on reviewing a few of these examples before we start with the next part. Okay, let me go to the notebook. I hope you should see my screen. Just give me a moment. What do I see? Chat messages. Okay. 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 So I was talking about indexing. Let me jump down. It's in slice indexing. And let me go to Boolean indexing. Okay. So Boolean indexing is the one that I think many of you faced difficulty last time. Uh, Boolean indexing is basically when I define an array like this. So we have defined an array with these values 11, 12, 21, 22, 20, 31, 32. And we want to extract a certain subset of this array. Let's say in our case, we want to extract all the values within this array which are greater than the number 15, okay? Which is basically looking at these 1, 2, 3, 4 values. Okay? So we can create a Boolean index by having something called as take the variable, write the condition here. So we are saying an array greater than 15. And I'm storing this answer into a variable called as filter. If I print the value of filter, we can see that filter is actually having the same size as the original array. Okay, so the same size as the original array, 3 rows and 2 columns. So we have 3 rows and 2 columns. And for each of these values, wherever the condition is met, that is wherever, in this case, wherever our an array is greater than 15, we have the Boolean value of true here. And everywhere else, we have the Boolean value of false. So using this filter, we can extract these values outside. So for example, we can say an array, and instead of passing row or column, we provide the variable filter, which is basically of the same size and having the values trues and false. Wherever we have the number true, it extracts for us these numbers. So an array of filter gives us 21, 22, 21, 32, because all these 4 numbers meets this criteria of greater than 15. Okay. Let me execute this. Uh, this variable filter need not be created as well. To an array, you can directly pass the condition in the square brackets. So there is no extra need for creating a variable and then passing it inside. So you can always write an array, and within the brackets you write the question, or you write the input, an array colon 2, modulus 2 equal to 0. So here the Boolean index that we're looking for will give us true values whenever the number is true, and whenever the number is not true or the number is false, we will get false. Okay. When the number is odd, we will get false. So whenever the number is true, it is able to extract those numbers out. So we have 12, 22, and 32 being extracted outside. Not just indexing, we could also do operation within the same line. So in this case, let's say we want to add 100 to all these Boolean values. We can write a code like this: an array, and within square brackets, write the condition, an array modulus 2 is equal to 0, thereby selecting all the even numbers and doing plus equal to 100. That is adding 100 to all the even numbers. So when we do this, we get this answer. Okay. Let me maybe ask you a question. So uh, let's say we want to select all of the odd numbers and we want to divide the odd numbers by 2. Can you tell me what code we should write here so that we can select all the odd numbers and we can divide the odd numbers by 2? What should be inside this condition? Okay, so I've got one answer which is right. An array modulus 2 should be equal to 1. And how do I say that all these values need to be divided by 2? Okay, you've got the first part right. The next part is I want that whenever these values are odd, I want these values to be divided by 2 as well. Okay, I'll complete the statement. It is divide equal to 2, and when I execute this, it says no loop matching the specified signature and casting was found. Oh, let us just first select this. Okay, selection works fine. I think we have to divide it this way. Let's try this one. Okay, and let's print an array. Okay, So dividing by 2, we see that it has returned to us integer values, probably because we started off with nd array being an integer variable. Okay, we could do something better by defining them as floats. So that is probably coming in this class. I will tell you ahead how do we define even the data types here. One option is I could simply start it with 11.0, and this would make all these numbers as floats. Let us repeat the steps. And now when we divide by 2, we get 5.5, 10.5, 15.5, and so on. So this is one way. That is, if I just put one of the values as floats, it will typecast the entire array, the entire numbers as floats. But there is a better way of doing this. I'll show that in the next session or in the next point that we'll talk about. Okay. Let us go ahead and look at arithmetic operators. So first, let me shift to my iPad. Okay, great. So if you remember our class on lists before, I said that there is a better way of adding a list of numbers together. And we saw one way using the function map, and using the map function we saw that we could add two lists, but that was still not a straightaway method. A much straighter method is using Numpy for our addition. So let's say if I have a matrix like this, if I have 1, 2, and 3 as a Numpy array, and let's say I have 4, 5, and 6 as a Numpy array. If I do an addition operation on them, what Numpy would do is it would add the individual elements together. Okay, so 1 will be added with 4, 2 will be added with 5, 3 will be added with 6, so that my final answer would be something like this. I will have 5, 7, and 9. Okay, so this addition will work out well within Numpy. So I can use all the arithmetic operators. In fact, I can use addition, subtraction, multiplication, division, square root, and exponential. And the list does not end here. We have many more things that we can do. You have to remember, when we are trying to add two objects, we need to ensure that both of them have the same size. Okay, within Numpy, as long as both of them have the same size, the condition will be added. So either they are row arrays, so rank 1 arrays, or it can also be rank 2 arrays. That is, if you are having a matrix. Let me try and show an example. If you have a matrix of this format, and you add it with, let's say, then you would get the answer as 2, 2, 4, 4, 6, 7. Okay. It would add each of the corresponding arrays as well. Okay. So even if there are two-dimensional arrays, each row element will get added to their corresponding row element, and each column element will get correspondingly added to their column elements, and so on. So hence we need to ensure that the size of both these arrays are the same. So here we have 2 rows and 3 columns. We need to add it with 2 rows and 3 columns. Okay. The same applies for addition, subtraction, multiplication. So what multiplication will do is, when you multiply these two arrays, we are presently not looking at matrix multiplication. What we'll be getting is individual terms getting multiplied with each other. Okay, so what will happen is you have 1 times 1, which is 1. This will be 0. This will be 3. This will be 0. This will be 5. This will be 6. Okay. So right now, when you try to do multiply, this is called as element-wise multiplication. Each element gets multiplied to its corresponding element, and that is what you get the answer as. Some people are asking, what if the matrices are of different size? Then, as someone said, it will throw you an error. It will say that this is not possible. Okay. and then you have to rectify the problem and then start again. So this multiplication we are looking at is not matrix multiplication. It is not dot multiplication. It is not dot multiplication. Okay, it is element-wise multiplication. To be able to do dot multiplication, we need to obey some different rules. The rules are the rows and columns here for A rows and B columns. We can only multiply it with B rows and any number of columns like C. As long as we are multiplying two matrices in which the columns of the first one is equal to the rows of the second one, only then we can do matrix multiplication. The way we can do matrix multiplication within Numpy is something like this. Let's say the first array, first matrix is called A, the next matrix is called B. Then there are different ways of doing matrix multiplication. One is we can do something like A dot B. Okay, and this can do matrix multiplication. Another way is we can do NP dot pass A and B. And the third way is we can do A at the rate B. Okay, so this at the rate symbol, this is my favorite form of matrix multiplication within Numpy. And this at the rate symbol is overwritten. It's overridden so that we can do something called as matrix multiplication. Okay. Anyways, when we go to the slide, we will look at some examples of that. Similarly, for division, instead of multiplication, if I use the division command, then each element here will be divided by the element here. In this case, I'm not sure if we'll get an error, or Numpy also has an infinite object. So it may give us infinite also. So again, we will verify this once we go to our slide, once we go to our notebook. Someone earlier asked, how do you implement square root? So the way square root works within Numpy is you call the function np.sqrt, and then you provide the matrix that you want to do square root of. So when we do np.sqrt a, each element of a, it will find out the root of each element of a. When I want to do exponential, I will do np.exp of a. So each element of a will be taken to an exponential. So basically you will have e raised to 1, e raised to 2, e raised to 3, and e raised to 4, 5, and 6 by doing exponential. Okay. Let me shift to the screen so that we can see these examples in live. Okay. So additionally, while creating the array, we can also define the type of the array. So earlier we saw to np.array we just passed one object. Now along with that one object, we are additionally passing the d type. D type stands for the data type. Okay. Now the data type can be integer, it can be float, it can be string, whatnot. But at this moment, we are trying for an integer data size, the data type. So when you write d type is equal to np.int, this matrix X will be treated as all integers. We can know they are all integers because they don't have a dot next to it. Okay. For the second array Y, we are using 211.1, 212.1, and so on. And here we write d type is equal to np.float, float 64. What this means is we get Y, which are float elements, which can be seen here by dot 1. So what is the default matrix genotype? As you would have seen in the first initial few examples, when we did not write any specification, what it did was it looked at the values or the elements that we have here, and if all the elements are integers, it said that an array will be created as integers. Whereas as I modified this example later on, and I put one of the elements as a float value, it took the default type as float. So Numpy in that sense is very smart. Depending on the data that you are passing to the variable, it will decide and you have not specifically told what to do, then it will decide the data type of the array automatically. Okay. So here we have two ways of specifically defining what we want to do. Okay, so here when we say int, it creates as an integer. When we say float 64, it creates it as a float 64 object. Okay, so now we have it here. So we have two variables x and y. Let us try a different arithmetic operators. So when we say x plus y, this basically adds the two matrices together. Each element gets added to its corresponding element. So let me also try to change the size and show you what happens when the sizes are not equal. So let's say I add x of, okay, so x is having 3 rows and 2 columns, whereas y is having only 2 rows and 2 columns. When I try to add them together, it throws me an error. It says that the operands could not be broadcast together with shapes 3, 2 and 2, 2. Okay. So there's a concept called as broadcasting, which I'll be discussing within this class. That will tell you what happens. So, okay. So maybe I made a mistake in explaining. Not always will the two matrices, if the two matrices are not having the same size, still we can add them if broadcasting is possible. Okay. Otherwise, it will throw you an error. So I will explain what broadcasting is very soon. So let me again rectify this for now. Execute this and show you addition. So we can do addition by simply doing x plus y. We can also do addition by using the numpy function called as add. So we can write np.add and provide x and y as inputs to this function. Both of them give us exactly the same answer. Similar to addition, we can do subtraction. So x minus y or np.subtract x comma y, both works the same. You can do multiply by x dot y, x multiplied by y, or here. So I made a mistake. Instead of multiply, I said dot. Oh no, dot is a different one. But we can do multiply using x and y as well. So you do np dot multiply with x and y, and each element gets multiplied to its corresponding element. We can do divide by saying x by y or np dot divide x and y. Again, that gives us division. For square root, we can use np.sqrt. That gives us square root. And for exponential, we can use np.exp. That gives us e raised to each of the elements of x. Let's look at x again. And we can also do other arithmetic operators, which I did not mention in the slide. So like sine, if I want to take the trigonometric transformation of each of these input values and get the sine value, I do np.sin x and I get this sine of each of these numbers. It's great. Let's say I want to do, yes, np.cos also works out. So there are many functions inside np that we can use. Let me see if this works out. Okay. So when I do dir.np, I can see what are the different functions inside. So generally the ones with capitals are, all capitals are not functions, these are attributes. And if I scroll down through this list, you can see all sorts of things. ABS, absolute, add, all, Amax, Amin, angle, A range, arcsine, and so on. Okay. So there's a huge list. Okay. I don't know what is the size. Let us try that. Okay, so there are some 622 different attributes and functions inside. There's a huge list. If you want to know more about this, you can either do help numpy, help np, and okay, so you can actually go to Google and get good help on numpy. And this is the documentation here. And you can see there are several things we can do. Array objects, constants, universal functions, and whatnot. Let me, okay, let's look at mathematical functions. And we've got many trigonometric functions. We've got hyperbolic functions, rounding functions, sums, products, and differences, exponents and logarithms, special functions, floating point routines. So there are so many things. You can easily spend 3 to 4 months just understanding NumPy. Okay, but let me again remind you, our journey does not end at NumPy. NumPy is just again one of the stepping stones that we are using so that we get closer to data science. Okay, that is our purpose. So even though we can do lots of things here, let's limit our discussion to only the main concepts. And the hope is if you understand the main concepts well, then you can easily go ahead and learn things on your own. Okay, let's go ahead. Uh, this is the size of x. So x is 2 rows, 2 columns. I create y as 2 rows and 3 columns. The purpose is then we can do a dot multiplication between two. So if I want to do a dot multiplication between this matrix and this matrix, I first ensure that my condition is satisfied. That is, the number of columns here is equal to the number of rows here. Same answer as earlier. Or we could use x at the rate y. And this at the rate is basically a representation of, again, matrix multiplication. So we get the same answer again. Okay. So 3 different ways of getting the same answer. And if one of you does not know what dot multiplication or matrix multiplication stands for, is you take the first row here, 1, 1, 1 and 1, 1, 2, and multiply it with the first column here. So to get the first value here, 2, 2, 3, we do 1, 1, 1 times the first column with the first element here, which is 1. Then add it with 1, 1, 2 multiplied by 1, which is 1, 1, 2 multiplied by 1. And when I execute this, we get the first element here as 223. Okay. So these are simple ways that we can do matrix multiplication and all the different arithmetic operators we saw within NumPy. Had we to do this within base Python, we would have to write a good amount of code writing functions that will take lists as input, that will operate upon them and give these answers. But NumPy makes our job much, much simpler, so that wherever we need arithmetic kind of operations, especially for linear algebra, calculus, statistical analysis, and so on, we can call the NumPy package and then get things done. Okay. So there are many, many more things that NumPy can do. Let me go to my slides and we'll see from there again. Sorry. Great. So now, commonly used statistical inputs. Okay. Someone is asking, sir, an array 1, 2, 3, user input array. How would you take an array as input? So, I'm not sure. I think once we come to the slide, let me try that, and then we'll see. Generally, generally for data science, we are not really interested to take many inputs from the user. Okay. For data science, primarily, we work with data sources like CSV files and other places. So taking input from users is something we don't do generally. And even if we do have to take inputs, 1 value, 2 values here and there is fine. But since you're asking, once we go back to our notebook, I will try to see how we can take an input array from the user as well. Before we go there, let us look at some of the statistical methods and sorting and set operations. So we can do mean, median, standard deviation. Can maybe someone write in the chat window, what do you mean by mean, what do you mean by median, and what do you mean by standard deviation? Once till you're writing, I will try to explain here. So if I have few values, let's say A1, A2, A3, the mean is the average, which is A1 plus A2 plus A3 divided by 3. That gives us uh, the average of all the data points that we have. That is, if I have to take all the sample data points and represent it by one number, a mean is a good sense of giving us an idea of where does it stand. What is median? Median is the center value. That is, we take all the elements, write them in sorted order. Once you write them in sorted order, if there are 5 elements, you go to the third element and say that that is my median. If there are 4 elements, then you take the average of the second and third element, and there you have your median value. What is standard deviation? So standard deviation is a measure uh, of how your data is distributed from the mean value. Okay, so generally, I hope you must have seen this curve, which is basically a bell curve or a Gaussian curve, depending upon how my data is. So if my data is normally distributed, this is what it looks like. If I take all the data and plot it in terms of frequency, the higher the value shows more frequency of this item. Lower value says less frequency of this item. Mean is generally the center point here. This tells us that that is the mean. Standard deviation is a measure of how much my data is spread. Okay. So this is one example. Another example of spreading could be something like this. So I would say that in the second case, my data is more spread out. Even though they may have similar means, the data is spread in a larger area. So my standard deviation is larger. Okay. And if my data is spread in a smaller area, I would say my standard deviation is lesser. Okay. Is the square root of average? Not really. It is the square root of these terms, right? Of these terms. So if you take the squares of individual points, sum them up, take its mean, and then take its square root, then you would end up with standard deviation. I'm not exactly sure, but I think that is where the standard deviation formula comes out. We use it. The symbol that is used to represent that is sigma, which gives us what is the standard deviation. Okay? So within NumPy, we can evaluate these things. So even though their formulas are fairly simple, you can write the formula yourself in a function and get the answer. But an easier way is within NumPy you can use inbuilt functions like np.mean, np.median, and np.std, standard deviation, to get these values for our data. Okay, so for our data, we can easily find the mean, median, standard deviation by calling these functions. Additionally, we have the sorting function. So we have np.sort that helps us to sort the matrices in different ways. Sort the matrices in different ways, that is, get them in ascending order, descending order, and so on. We also have functions like union, intersection, and difference. So these are things that we saw, if you remember, when we did our the data type called as sets. So sets was a data type within Python, and we could do union, intersection, difference. Similarly, even with NumPy, we can do unions, intersections, and differences as well. Okay. Okay. Let me go to the screen slide, and we'll explore this idea. So first, before starting this part, let us try to take an input from the user to get an array. Let's write that. So I'll say, let me say, array is equal to input, enter array, and when I execute this, let me put the values 1, 2, 3, and let's see what happens. Okay, so this got executed. When I check array, oh, it comes as the form of a list, right? So let me try to do some more modification. If I do list of this and I execute this part, now when I put 1, 1, 2, 3, and when we see an array, oh, it takes a list of each of these elements. So I have to do something more. Let me do int of this as well. Let me take int outside, then try it. Okay, if not list, what happens? Or I can do it much easier by doing a very quick Google search. Let's say Python input. So no direct way. It is telling take the number of elements and then run a loop. Let me check if there is an array. Okay, input the number, map int to strip split and map. Okay, this is one way which is a bit complicated, but it is using the int that applies it on this idea. Okay, so this is possible. Let's go ahead. Okay, okay. Okay. Yeah, no clear cut, no single clear cut way of getting it. So there are multiple solutions that can be done. It's a very specific problem. Okay. So I liked this method, the map method. Let us try it out and see if it works. We copy this. Okay, here, paste it up here, and let's remove this part. Okay. Let's say we are entering a matrix of n is equal to 3 elements. And if I execute this and I put, okay, 1, 2, 3. Okay, let me execute this again with 1, 2, 3. And when I look at A, yeah. So since there is no clear-cut way, we have to come up with an idea of how we want to read inputs from the user, and there are different strategies here. So here we are giving with separating the numbers using spaces. That comes as input here. When we do a dot strip, that removes all the spaces in the beginning and the end. And then we do a dot split. And when we do a dot split, it is separating these elements into single string elements. And then we do integer or map it with integer. So it converts all these strings into integers and then connects that into a list and then gives us the answer. Okay. Or we can run a loop. Okay. So either ways, there are different ways of doing this. As I said earlier, okay, this is not a very important problem, especially someone is telling try eval input. Okay, let me try it. So eval input. Sorry. Okay. And if I pass 1, 2, 3. Oh, excellent. So let's say L is equal to this. And we can see the data type of L. Awesome. So who said this answer? Vijaya. Okay. Thank you so much. You saved us with a lot of work. Okay. So anyways, let's go ahead. Okay, let's go ahead. Let's look at statistical methods. So before going to mean and all, let us create some random data for us. So we are starting with this data, np.random.random. So that is within the Numpy package, the random module. And n is basically giving us random numbers which are coming from a normal distribution. The n stands for normal distribution. Okay, and we say 2 comma 5, which is 2 rows and 5 columns, and we multiply each of these elements by 2 and we execute this. So when we do that, we get this list of 2 rows and 5 columns with random numbers. Just to show you that they are random, I can try and execute this multiple times. You can see every time that I execute, we get different numbers from the random list. When you look at the type of array, we can know that this is a Numpy array. Now, since it's a Numpy array, we can do several operations on it. So we take the variable ARR and find its mean by simply saying ARR.mean, and that gives us the mean value. So if you take the mean value of all these elements, that is, you add all of these elements and divide it by the number 10, you end up with this value. But sometimes we would want to do something different, right? You would want to know what is the mean of the rows. So if I just take the first 5 values, this row here, and find its mean, and then I want to take this row and second row and find its mean, I can do that by specifying the axis to mean. I can say ARR.mean with respect to the axis 1. So axis 1 means compute by a row. Okay, compute the means by a row is what we mean by axis 1. So when you do that, it says, okay, these 5 values, the mean comes to be 1.44. And for these values, the second row, the mean comes to be 4.10. If I want to find the mean for each of the columns, we can provide axis 0. And when we do that, we can see that the mean of 8.3 and 1.9 comes to 5.11, 5.11, and so on. Okay, so we can find the mean for each of the columns with using this strategy, axis 0 and axis 1. If I want to find the sum of all elements, that is, what is the sum of all elements, we can use ARR.sum. That gives us the sum of all the elements. And similar to finding mean based on row, we can also find sum based on axis 1 and axis 0. So axis 0 finds the sum of all the rows. Axis 1 finds us the sum of all the columns. Okay. Additionally, we can do median with the same strategy. What is the median for axis 1? We can do standard deviation. We can find the standard deviation for axis 0, axis 1, and so on. Okay. So these are simple ways where we can do basic statistical operations within Numpy to get mean, median, sum, standard deviation. I'm sure there are many more statistical features that we can use, but to get an idea of what they are, these examples are enough. Let's go ahead and we can also see how to sort elements. So here we are starting with 10 random elements that creates with, yes, axis indicates rows and columns. Axis is equal to 0 indicates columns, and axis equal to 1 indicates rows. Okay. When we go for sorting, we can see we start out with 10 random numbers from the normally distributed set. This goes into the variable unsorted, and we can see that they are in fact unsorted. They are not in any order. Now we can do stuff with that. Okay, so first I'm creating a copy of unsorted within a variable called sorted. So np.array unsorted, I create a copy in sorted, and within this sorted variable, I am doing sorted.sort. Okay. So when I execute this, you can see that sorted.sort. So sorted looks like this. It has sorted into the right strategy. That is, I have the least value here, followed by other values, and then the max value here as well. And we also see that the variable unsorted has not changed. The variable unsorted has the same value as before. Okay, so this is possible because we created a deep copy here. When we created np.array and we created we created a deep copy, and by changing sorted variable, unsorted variable does not get affected. Okay. So simple to sort variables within Numpy. Let's go ahead. We can also do set operations, okay? Like we did sets within the data type sets, we can do multiple set operations within Numpy. Let's look at this example. So here we are creating an array with multiple elements, 1, 2, 1, 4, 2, 1, 4, 2. And if I just want the unique elements, okay? So within Python, we said that if I take a list and convert that into a set, all the duplicates will be eliminated and we will be left with the unique elements. Similarly, if you want to do this with NumPy, you can call the function np.unique, and calling the function np.unique gets rid of all the duplicates, and you end up with just unique elements. So here we have 1, 2, and 4, which are the unique elements within this array. NumPy can also deal with strings. It is not necessary. So far, even though we have seen examples of integers and floats, NumPy also deals with strings. So when I have np.array, and these are the 3 string elements in set 1, S1, we have desk, chair, and bulb. And in set 2, we have lamp, bulb, and chair. Okay. So when I print these 2 values, we can see that it actually forms NumPy arrays with these elements as with these values as elements inside the array. If we check at its type, we can ensure that these are ND arrays. If I want to find the intersection, that is, what is the common elements between these 2 guys, we can call the function np.intersect1d. Okay, np.intersect1d, and it finds us the intersection. So within these 2 sets, the intersection is chair and bulb. So it gives us this answer as bulb and chair is the intersection between these 2 guys. If I want to find a union, that is, what are all the unique elements in the entire combinations of S1 and S2, then we can do np.union1d, and we can see that we have 4 elements now: bulb, chair, desk, and lamp. We can also do set difference, that is, from the set S1, if we subtract the set S2, you will see that desk, chair, and bulb. So chair and bulb will get extracted, and lamp, since it never existed within S1, lamp also lamp is not there altogether. Okay. So when we do np.setDifference1d, we see S1 and S2, and we can see the answer as desk here. We can also do in 1D. So in is basically helps us to know which elements of S2 are also present in S1. Okay. So which elements of S2 are also present in S1. So you see here desk, chair, and bulb. So within S2 we have bulb and chair, which are present in S1. That is why you see true and true here. Otherwise you see a false. Okay. So 1D I think is used for one-dimensional array. Since you're dealing with one-dimensional array, we're using 1D. Let me quickly check if there are 2D functions also. So I can do np dot. So there's a quick hint here. Okay, if I'm using Jupyter Notebooks, you write np dot, and when you press the tab button, you can see a list of items that are contextualized for this function. So now I want to see, let's say, intersect. So I write INTER, and I see that there is only one-dimensional intersection available. I don't have two-dimensional intersection. So probably if I have two-dimensional items, let me quickly try and see. I guess it will throw us an error. So this is, let's make a list of items like this. And let us change some elements as spoon, that is our S1 and S2. And now if we want to do, let's say, union between these 2 guys. So what it does is oh no, great. So it converts that into one dimension, and then it operates on that one dimension. So irrespective of you have multiple, if you have a matrices with multiple rows and multiple columns, it reads all the elements as one set. And for that set, it is able to do different operations. Hence the intuitive term that it converts into 1D, one dimension, and then works on that one dimension. Okay. I hope that helped you, and I also got to learn something new. Let us go ahead and look at the next important concept called as broadcasting. So NumPy needs indentation. So by indentation, you mean if I write a command like this, this will throw an error. okay, within Python. So NumPy is part of Python, and Python says that you have to give indent only when you're starting a loop or you're starting a bracket kind of structure. Okay, here this would probably throw me an error. It would say that an indentation error. So the same rules of Python apply for NumPy also as well. Without indentation, it will throw you an error. Without proper indentation, it will throw you an error. Okay, let's look at broadcasting. So I'll shift to my screen. And we'll look at three kinds of broadcasting that is possible: row broadcasting, column broadcasting, and scalar broadcasting. And we'll also see what does this mean. Okay. So as I said earlier, let me create a matrix like this. And let's say this is your A. If I want to add to this, I said that it should have the same dimensions. The matrix B should have the same dimensions as the matrix A. The dimensions of matrix A are 2 rows and 3 columns. Now I change my statement saying that if I add a column like matrix like this, okay, when I take a matrix and here the size is 1 row and 3 columns. So long as I meet the condition that I add a row matrix here, okay, a row matrix which has the same number of columns as the first case. In this case, we have 3 columns, and in the second case, even if I have 3 columns, interestingly, what NumPy will do is NumPy will add these 2 elements, and the first column, the first row will be like this. I'll have 2, 3, and 4, and the second row will become 5, 6, and 7. So what basically it is doing is it is taking this single row matrix and broadcasting it to both these guys. Okay, so NumPy is interpreting this one as 1, 1, 1, 1, 1, 1. So what it is doing is it is broadcasting this one row as 2 rows so that the dimension here matches, and then you are able to add element by element. Okay, I hope you got this idea. Let me, and if you have gotten this idea of row broadcasting, you would also understand column broadcasting. And let me ask that question and verify if you've got this. Okay. So if I do something like this, can you tell me what will be the answer? Okay, so here as well. Okay, okay. So yes, I think many of you are getting it right. So what will happen is, what NumPy will do is it will broadcast this one column into multiple columns. Okay, so it says that okay, the size here is 2 rows and 1 column, but I'm adding it to an element with 2 rows and 3 columns. So it says, let me extend this idea and convert this into something like this: 2, 1, 2, 1, 2, 1. So it takes this one column, converts that into 3 columns, and now when I add these 2 together, my answer will be 3, 4, and 5, and here 5, 6, and 7. So all of you guys who wrote this answer, this was right. So it will broadcast the columns accordingly. Okay. So we saw both kinds of broadcasting: row broadcasting and column broadcasting. Scalar broadcasting is again the very same idea. Okay. So instead of having a row or a column, we have just one value. So if I add, let's say if I broadcast it with the value 1, what will happen is the value 1 will be added to each and every element of A. Okay, you will end up with 2, 3, 4, and 5, 6, 7. Okay. So we saw what broadcasting is doing. Okay, so it sees that if the second element is a row, if the second element is a row, does it have the same number of columns as the first? If it has the same number of columns as the first, Numpy will duplicate the number of rows so that you get to the same size as the number of rows. You already have the same number of columns, you can add them together. Okay. For columns, what it will do, it will check if the number of columns, it will check the number of columns, the first one, the number of columns for the second one. If I have a column matrix that is one column, but the number of rows are right, I have the right number of rows, it will duplicate as many number of columns so that they both become of the same size, and then you can add them together. And that is column, broadcasting. And finally, we look at scalar broadcasting. And scalar broadcasting is when I try to add to a matrix, I add a scalar, it will broadcast this value to each and every element of the matrix for all rows and for all columns. Okay. And when we do that, it simply adds this constant value to every element. Okay. Let me quickly go to this to my notebook, and then we'll look at how this is done. Okay. So a few questions. If suppose 3 cross 1 matrix, then 3 cross 1 as the first one, I'll have to look at difficult to get what you're asking with just one line. Always it takes first matrix rows and columns. Yes, first matrix rows and columns are held as priority. So let's look at this case. So here I start with okay, second matrix is 3 rows and 1 column. What is the first one? Let me finish this examples. Hopefully it will answer your question. If not, then you can explain your question in detail again. Okay. So we start with np.zeros with 4 rows and 3 columns with all zeros. So we see 4 rows, 3 columns with all elements as zeros. That is in my variable called as start. I add one row matrix with 1 row and 3 columns as 1, 0, 2. That is my variable add rows. Now, normally I should not be allowed to add these two ideas, these two matrices together because they are of different sizes. But with broadcasting, I can see that I have 3 columns here and I have 3 columns here. So when I add them together, start plus add rows, what I see is this row 102 gets added to each of the rows of the start matrix. So I end up with 102 here in the variable y. Similarly, I can now create a matrix called as add cols. So here I'm creating a column matrix. The way I'm doing that is I'm creating, let me show you. Okay. So let us do this in parts. Let's just take this part, and when I add it here, let's see what happens. So when you create this, it creates a rank 2. Item of 1 row. Okay, so this is 1 row and 4 columns right now. But what I want is I want 4 rows and 1 column. So we are doing a transpose over it. The way we are doing a transpose is by doing a dot t to it. So when you do a dot t does a transpose. A transpose is a simple operation which converts rows into columns and columns into rows. So here we have 1 row and 4 columns. When you do a transpose, it makes it as 4 rows and 1 column. Okay. So that is the column matrix that we are creating, called as add cols. Now we can take this add cols. And add it to start. You remember start was all elements with zeros. Now when I add it together, what it does is it adds to each of the column, it adds the values 0, 1, 2, 3, and we get this answer. Finally, we look at a scalar value. So we create one constant value, say np.array with one single value, and that is our scalar. And when we add these two together, that is start plus scalar, we can see the scalar value of 1 gets added to each and every value here. So let me take a few questions. So someone said first matrix and not. Let's simply verify. So we know this what this returns to us. Okay, this returns to us add calls in all these ways. But if we do the opposite, that is, we do add calls plus start. Let's see what happens. So, okay, interestingly, the order does not matter. Numpy just sees if they can be broadcasted or not, and if they can be broadcasted, it gets added together. Okay. Now, first matrix is 2 cross 3 and second matrix is 3 cross 1. So let's try that. First matrix 2 cross 3. So let's say first is equal to np dot zeros. First matrix is 2 cross 3. Okay. Let's take another matrix. Second matrix with all, let's say, ones, with 3 rows and 1 columns. Okay. That is second. So now we have this and this. The question is, if we try to add, so I don't think this can be added together, because neither row broadcasting will work out, neither column broadcasting will work out. So it will probably give us an error saying that these cannot be broadcasted together. Okay. Yes, operands could not be broadcasted with these values. So to broadcast, I need to have same thing, right? So here, if this matrix is 2 cross 3, I can broadcast it with a row matrix only when I have 1 row and 3 columns. I can broadcast it with a column matrix only if I have 2 rows and 1 column. Okay, so this does not meet both of these criteria, hence the broadcasting will not work out. Let me just simply modify this one to make it 2, and when I add this part, you can see that this broadcasting works out well. Okay. So can you share the notebook with us? I have already shared the notebook. You have to contact your host to see how you can access it. So we will stop here for today. In the next class, we'll look at some more things that we can do with NumPy. And the majority, the one item of importance that is left is vectorization. And vectorization is very, very useful because it helps us to write compact equations, to take complex equations, write them in a compact form, and also save on time and memory. Okay, so vectorization is very important, and we'll look at that in the next class. Okay. So I'll stop sharing for now. Okay, and Neeja ma'am, I'll stop for today. Okay. Thank you so much for attending. See you guys in the next class. Bye-bye.
మీకు నోట్బుక్ వచ్చేసి మీకు అప్లోడ్ చేయడం జరిగింది. మీ లాగిన్స్లో ఒకసారి చెక్ చేసుకోండి. అదర్వైజ్ నేను మీకు టెలిగ్రామ్లో కూడా లింక్ షేర్ చేయడం జరిగింది.